Before we jump into the declaration, understanding what is significant, the molecule gas pedals are the Huge Hadron Collider LHC worked by CERN. It is a 17M ring of superconducting magnets, and also the world's biggest and most powerful atom smasher. It represents the apex of human logical accomplishment. As a matter of fact, it's so powerful that it can reproduce the very states of the universe's introduction to the world. But could this machine, intended to open the mystery of the universe, hold the key to something undeniably more unpropitious? CERN, established in 1954, is one of the world's most renowned research associations with 23 member states and a vast number of researchers. It's a center for cooperation and innovation. The LHC is CERN's leader project, yet it's only one section of a huge network of gas pedals and tests. Imagine a course not for vehicles or horses, but for subatomic particles in a test of skill, endurance, and space itself. The LHC speeds up protons to almost the speed of light, sending them on a crash course that imitates the energy of the universe at the moment of the Big Bang. The impacts make temperatures multiple times hotter than the center of the sun. A large number of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC are made to crash at 4 areas around the gas pedal ring, corresponding to the positions of 4 molecule locators: Atlas, CMS, ALICE, and LHCb. Each serves a special purpose, investigating unique parts of particle physics. Together, they act as giant cameras capturing depictions of these crashes. Researchers then filter through the debris searching for indications of the tricky Higgs boson, also known as the God particle, and other phenomena that offer pieces of the universe's fundamental building blocks. By concentrating on the microcosm, we gain insights into the cosmos. But with each answer comes another question, and with each discovery, another test. The LHC isn't just a scientific instrument. It's a demonstration of human curiosity and innovation. It encapsulates our persistent quest for knowledge and our craving to grasp the key powers that shape our universe. But as we push the limits of what we know, we must also consider the moral and existential questions that arise. What are the dangers of examining the unknown? Could our mission for understanding accidentally open powers we have no control over? In the hallowed halls of CERN, where the limits of human comprehension are constantly pushed, a discovery has emerged that sends a shudder down the spine of even the most prepared researchers. Brian Cox, a former scientist at CERN and a voice of expertise in the realm of particle physics, has recently made a declaration that has left the world both fascinated and apprehensive. Cox's words resonate with chilling clarity. The objective of CERN's Large Hadron Collider is to reproduce a small-scale Big Bang. Yes, you heard that right, a mini version of the very event that brought forth our universe. The physicist also happened to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant part of the universe. Imagine holding the power of creation in your hands, the ability to invoke the very essence of the universe. It's an enticing possibility, but one laden with risk. The mini Big Bang is not just a theoretical concept. It's a tangible reality inside the LHC. The temperatures, the pressures, the raw energy, all replicate the conditions of the universe's inception. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something went terribly wrong back in 1978. The Russian physicist Anat Borsky encountered a catastrophe that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Puso, Russia, a glitch caused his head to accidentally come into the direct path of a proton beam. The beam, with a force that defies comprehension, went through his skull, entering the back of his head and exiting through his nose. Borsky's experience was intense. He saw a flash brighter than 1,000 suns but had no worries. The beam's path left a trail of destruction, burning tissue and bone, yet he remained conscious and even walked to the center for treatment. The result was both alarming and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. But incredibly, Borsky's intellectual abilities remained intact, and he continued his scientific career. This episode is not just a personal tragedy, but a wake-up call that highlights the immense power and potential danger of particle accelerators. The risks of an atom smasher like the LHC are not to be underestimated. The potential for unexpected reactions, the very fabric of existence being altered, these are not the stuff of science fiction but real concerns voiced by some esteemed scientists. One of the most disturbing and captivating concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are enormous vacuum cleaners, devourers of stars, mysterious entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a minuscule scale, is staggering to both the public and scientists alike. Could this black hole eventually grow uncontrollably, swallowing the Earth from the inside? Researchers at CERN have assured the public that any black hole created would be unstable and disappear almost immediately. Yet, the remote possibility has sparked discussions, fears, and a sense of wonder at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the basic mechanics of particle accelerators. When protons are crushed together at nearly the speed of light, the energy produced is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be pulled into it. This is a simplified analogy for what could happen at the LHC in the realm of quantum physics, where the rules of the universe are both strange and wondrous. There exists a theory that extra dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a tiny black hole. This baffling dance of particles has even captured the attention of some world-renowned scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a devastating vacuum decay, a cataclysmic event that wouldn't just destroy the Earth, but could potentially obliterate the entire universe. The esteemed English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the potential dangers of particle accelerator experiments, including those at CERN. His words were not just cautionary. They were imbued with a sense of existential dread. He spoke of the worst-case scenario where a doomed experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, resulting in a cosmic disaster that could engulf the entire universe. Rees' concerns were not limited to theoretical musings. He assigned a low probability to these catastrophic outcomes. However, he argued that even a small chance warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The researchers at CERN have run simulations, analyzed the theories, and taken steps to ensure the safety of the LHC. In fact, Brian Cox himself acknowledged the significance of this, recognizing the widespread apprehensions and concerns surrounding the activities at the LHC. He emphasized that there are thorough safety measures in place, comprehensive reviews, and protocols to ensure that the LHC's operations are conducted with the utmost attention to detail. Cox reassured that the energies involved are well within what the Earth naturally experiences, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so minuscule and unstable that it would dissipate almost immediately in a burst of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a brief moment of cosmic wonder, just a glimpse into the abyss and then gone. Some have gone further, theorizing that the LHC's experiments could open a gateway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many and become a subject of interest, fear, and even myth. What lies beyond our universe? Could we accidentally release forces or entities that we don't understand? The notion of opening a door to hell has even been sensationalized in various media, fanning the flames of uncertainty. But how did this idea come to be, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but they might theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key unlocking doors that have been sealed since the dawn of recorded history. When protons collide at energies never before achieved on Earth, they could, in theory, create waves or ripples that probe these hidden dimensions. If these dimensions exist, the LHC could potentially reveal them. But before we get carried away with wild speculation, it's important to understand that while the LHC is undoubtedly powerful, there is no definitive proof to suggest it will open a door to another universe, let alone hell itself. Nevertheless, the allure of the unknown, combined with the enigmatic nature of quantum physics, means such ideas will continue to captivate the public imagination. So, should we be concerned about the LHC and its potential risks? It's easy to be swept away by sensational headlines and fears of cosmic catastrophe. But the truth is, the scientists at CERN are well aware of the risks involved. They have taken every precaution to ensure their experiments are safe, and they continue to monitor and assess their work with the highest level of diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter, are truly remarkable. It's not just a demonstration of human ingenuity, but a window into the very heart of the universe. However, like any great leap forward in science, it comes with its share of risks, and we must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the cutting edge of scientific investigation, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. But despite rigorous safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer scale of the machine and the energy it generates is awe-inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of LHC experiments, there are obvious uncertainties. What if new, unexpected phenomena emerge that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As particle collisions recreate conditions not seen since the Big Bang, the profound nature of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Nevertheless, the LHC's achievements in particle physics have been groundbreaking. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that could reshape our technological future. Despite the risks, the pursuit of knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments delve into realms of physics where intuition no longer applies. For decades, physicists have tried to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a crucial role in the structure of matter. The LHC has been instrumental in providing clues, bringing us closer to a unified theory of everything, where all these forces may be reconciled under a single framework. As humanity continues to explore these frontiers, the very nature of these experiments has raised profound ethical questions. Could advances in particle physics lead to unintended consequences for our planet or even for the fabric of reality itself? These are difficult questions to answer, and they require careful thought about the broader implications of scientific progress. For example, the creation of exotic particles or the study of high-energy conditions might reveal hidden aspects of the universe, but they also carry the risk of triggering new phenomena that are difficult to predict. The Large Hadron Collider, LHC, stands at the pinnacle of scientific discovery, a monument to human curiosity and ingenuity. As we venture deeper into the subatomic world, we are not just testing theoretical boundaries but also exploring fundamental questions about the origins of matter, energy, and the cosmos. While the LHC's primary goal is to unravel the mysteries of particle physics, particularly the Higgs boson, its broader implications extend far beyond its immediate scientific objectives. One fascinating aspect of the LHC's research is its potential to unlock the secrets of dark matter and dark energy. These mysterious forces make up a significant portion of the universe, yet remain largely invisible and undetectable. Dark matter, which exerts gravitational pull on visible matter, and dark energy, which accelerates the expansion of the universe, remain two of the most profound puzzles in astrophysics. By studying particle interactions at the LHC, scientists hope to identify particles that could shed light on these unseen forces, potentially revolutionizing our understanding of the universe. Another exciting aspect of the LHC's work involves the search for supersymmetry, a theoretical framework that proposes a relationship between the fundamental particles of nature. Supersymmetry could explain a number of unresolved issues in physics, including the nature of dark matter and the imbalance between matter and antimatter. However, the discovery of supersymmetric particles would not only validate one of the most popular theories in modern physics, but also open the door to entirely new realms of inquiry and exploration. As we push the boundaries of knowledge, the LHC also raises important questions about the nature of science and technology. While many researchers are confident that the collider operates safely within the confines of our physical laws, the risks associated with unknown phenomena are inherent in any groundbreaking scientific experiment. As such, the responsibility to carefully monitor and assess each step of the LHC's work is not just a matter of technical safety but one of ethical concern. The pursuit of knowledge must always be tempered by a respect for the potential consequences of altering the fundamental fabric of our universe. In this sense, the LHC is not merely a tool for scientific exploration but also a reminder of the delicate balance between discovery and caution.